Okay, so next problem is 683. The wall crane supports a load of 700 newtons. Determine the horizontal and vertical components of reaction at the pins A and D. Also, what is the force in the cable at the winch W? Um, okay, so we have a system, a crane, which is supported to the wall at point A and D. We have pulleys at point B and C. There's a free pulley at point E, and there acts a load of 700 newtons on the hook, to the hook. The cable from winch to the pulley B makes an angle of 60 degrees. This is given. Distance from point A to B is 1 meters, and distance from B to C is given as 1 meters as well. And also distance from A to D is given as 1 meters. Now, we will begin analyzing the problem from the point E, and we will write the free body diagram of pulley E, and then we will go step by step and draw and write the equilibrium equations for each component of the system, machine. Now let's begin with the pulley E. As you see, there acts a force of 700 newtons. Certainly, tension in the cable is represented as TE here. Again, we say that the horizontal component of the axis is X and vertical axis is Y for all components. So as a result, sum of the forces in Y direction has to be equal to 0. From here, we can say that the tension in the cable is 700 divided by 2, and that's equal to 350 newtons. Now let's focus on the pulley C. Since the tension in the cable is constant through the cable, we have force TE and TE on either side. Certainly, there is a reaction force that comes to the pulley, and obviously we can say that it makes an angle of 45 degrees with the horizon. So this angle is 45 degrees. From here, we can say that FC is equal to square root of 2 multiplied by TE. Therefore, TE, FC, the force which comes to the pulley is 494.975 newtons. Now let's continue to follow the cable. Now next, it passes through the pulley B. Again, the tension in the cable is constant. It is TE. So we have one force here, and the other TE is here. So remember that this angle is 60 degrees. As a result, this angle is 120 degrees. Therefore, I can easily say that FB is equal to TE from here, and that is equal to 350 newtons. Now let's focus on the rod AB. Now, if you look at the, let's return back to the figure. So now first we look at the AB. As you see, it is pinned at point A. The rod DB is connected to the rod AC at point B, and then we have the pulley, and then we have the pulley at C. Certainly, on rod B, we have FC, we have FB, which comes from the pulley, and we have the force which comes from the rod. At point A, we have two reaction forces. We don't have any moment since it is pinned at point A. Now let's draw the free body diagram. So we have FB force which comes from the pulley. It makes an angle of 60 degrees. We have By. I choose the direction in negative Y. And then we have Bx. I choose it in positive X direction. We have Fc, which comes from the pulley. And in fact, we have the tension in the cable, because this free pulley at E is connected to the point C. So at point A, we have two forces, AX and AY. So this is the free body diagram of the rod AB. We choose counterclockwise direction as positive. Now let me write the moment equilibrium. So I choose the point A for the moment. So sum of the moment with respect to point A has to be equal to 0. So first I have TE, so minus TE multiplied by 2. So remember that FC makes an angle of 45 degrees. So minus FC multiplied by cosine 45 multiplied by 2. So we have the By multiplied by 1, minus FB sine 60 multiplied by 1. And this has to be equal to 0. Now in this expression, the only unknown is By. So By is equal to minus 1703.11 newtons. From here, I can easily calculate the Bx, because I know that rod DB will carry load only along its direction. Since it makes an angle of 45 degrees, again Bx will be equal to By. As a result, it is minus 1703.11 newtons. Let's continue. Sum of the forces in my direction has to be equal to 0 for the AC, rod AC. So AY is equal to minus FB multiplied by sine 60 minus By minus FC multiplied by sine 45 minus TE. In this equation, only unknown is AY. So we have calculated the FB and FC, and we have just calculated the By. From here, you can obtain the value for the AY as 1003.11 newtons. Next, sum of the forces in X direction has to be equal to 0. So AX plus BX plus FB multiplied by cosine 60 minus FC sine 45 or cosine 45, doesn't matter. So let's correct it, that's better. This will avoid confusion in you. FC multiplied by cosine 45 is equal to 0. From here you can obtain the AX. AX is equal to minus 1528.11 newtons. Now let's focus on the rod dB. Now I choose the reaction forces in dy in positive y and in positive x direction. Because of the choice of the forces at point B on member rod AC, the direction of the forces has to be reversed for point B. So By is in positive and Bx is in negative x direction. As a result, dx is equal to Bx. From here, it is minus 1703.11 newtons. And dy is equal to minus By. So it is 1703.11 newtons.